for Hayle Brown from Louisiana. She's the Assistant Bridge Maintenance Engineer, currently the engineer over the LDOT's in-house bridge construction and repair crews that operate statewide.
All right, so Louisiana is divided into 9 districts, and each district does have a bridge maintenance crew, and they typically work with timber bridge repairs. We have a lot of timber bridges and a lot of timber pile bridges, so a lot of their repairs are timber piles. They also do deck repairs and joint repairs. And then if they have movable bridges in their district, which is usually the southern districts, they have mechanics and electricians that help, keep those bridges opening and closing. I am over a statewide crew that operates from headquarters, so that's my focus of the presentation. What we do from my crews is, number one, we replace bridges with concrete precast panel bridges. And we do end-on construction, and I have 2 crews that primarily only replace bridges. And the bridges we're replacing are ones that don't make it to their letting date. They either have to be closed and there's no more repairs that the districts can do, or they get low posted so low and it's on a truck route. So the easiest thing with a lot of these type bridges is we'll just come in and build a new bridge. So I have 2 crews, and they both work 8 days on, and then the other crew comes on, and the other crew goes home for 6 days. So we are constantly building bridges. As far as bridge repairs, we do helper bents, usually steel helper bents. We'll fix bearings or try to rehab bearings, retrofit a lot of steel members, either to help strengthen where there's section loss to keep a bridge from getting posted too low, or to maintain a posting. And then we have a water crew that does fender repairs, among other things at movable bridges that we'll get into. So this is an example of our end-on construction, and you can see that is a lovely timber bridge. My only guess is Louisiana has a lot of lumber, has a lumber industry, and years ago they built a lot of state bridges using timber, and they decay pretty quickly once they start here because of the humidity and whatnot. This is what our typical bridge looks like. We do steel pile bents, concrete caps, concrete spans. And we pull out a span, build the first bent, and then come back and build the abutment, and then lay the first span, and then just move on that way. And we typically try to stick with straightaways and highways that can be closed. With the 2 crews working, a 4-span bridge will usually take us 6 weeks to replace. So this is a longer span bridge that we had to do after the 2016 floods that we had in our state. As you can see, we do battered piles when we need to. Depends on how high the bridge is. All right, so bear with me on this video. We had to buy new cameras, and we didn't know how to take out the night scenes. So once I get my new cameras, we'll have an updated video. But this is our time lapse of a bridge replacement. This was a single span bridge that got washed out in North Louisiana in 2016. And I think they got it replaced in a matter of 2 to 3 weeks. It was just a 2-span bridge that we went back with, or 3-span, I can't remember. And so we have in-house, we have cranes and excavators and hauling trucks and all the material equipment that we need in order to replace these bridges. And so typically we're replacing bridges on highways with lower ADTs, or highways that have that trucks use, lumber mainly. Sometimes we do have to go do emergency replacements, and then bridge design will come back, and like NHS bridges, they'll come back later on and replace it to make sure it meets the criteria required on a national highway system bridge. So moving on to our water crew, we have lots of movable bridges. I think Louisiana has the most in the country. And our movable bridges have fender systems. Well, you can see the fender system, that overhead, that's where the boats are supposed to go, between those 2 fender systems. They don't always do that, but we'll get to that. So this is our equipment that we have a tug. It's in the back, you can see. And then we have an equipment barge, which our crane sits on, and other equipment and material. And then the one sitting in front is our material barge. And we just move all over the state, going to bridges, mainly in navigable waterways that have fender systems that get hit. And then while we're there, we'll do whatever the district may need help with to make repairs, do preventative maintenance, whatever they need help with. So this is a damaged fender system. This happens a lot. As you can see, it helps protect the bridge. At least they're hitting that, not the bridge, but your nav lights are on it, so you usually have to get them fixed so you can fix your navigational light system. This is another picture of the tug and barge. So that's just from the wheelhouse of the tugboat, and that's the viewpoint. So you can see our crane. New fender system. I guess those slides got out of order. So this is what it looks like afterwards when we're done rebuilding a fender system. And then we move on to the next fender system. This is some retrofitting we've done. It's just to give you an idea of what we can do. A lot of movable bridges on water end up needing to be beefed up. They get, there's a lot of corrosion when you're that close to the water. So we go in and add plates to help strengthen the bridge after it's corroded until it can be rehabilitated through bridge design. And it's just another example of what we do. Add plate, bolt it. This was a good project. I think this one was in North Louisiana, and these old rocker bearings, completely corroded. You can see that one is pretty bad off once we jacked up the bridge and it fell out. On the left over here, the rocker bearing was beyond rehabilitating. So we used some of our H-pile cut off, turned it over, welded a plate to it, coated it, painted it, and put a neoprene pad on top. And then on the other picture is a rehabilitated rocker that we blasted and painted and reinstalled. Helper vents. This bridge was literally sinking. It's over Salt Bayou, and to get it to its letting date, we had to go install some helper vents. So we cut holes, drive the piles, weld plates, install steel caps. That's the after, form everything up, coat everything. We paint our bridge piles. We do a zinc, and then we coat it with coal tar epoxy. And when we're working South Louisiana, we'll do like 3 coats of the coal tar, what it looks like afterwards. And that's a pretty typical repair for timber bridges, concrete bridge, any bridge where we're having problems with caps or piles. My crew would just rather go in and drive some helper vents. But they'd actually just like to replace the bridge. That's easier, but it's not always feasible. So if you have any questions, I'd be glad to answer them. But.
You're on your piles. How are you establishing pile capacity, and what type of hammer are you using? And looks like you're driving all timber. Why aren't you driving something either concrete or steel shell piles?
So concrete. So like in South Louisiana, we end up having to drive, 160, 170 feet a pile because it's literally like peanut butter. And a lot of our projects are emergency based. And so concrete is not feasible because you have to have a designed pile length that you have to have them precast in advance. We do steel, that's what we have the equipment to handle, and our geotech section will give us a length to aim for and come to a restrike after we've driven and let it set up. So that's usually how we establish our length and pile to get capacity. And the geotech section doesn't recommend that we go concrete. They're like, no, stick with, that's a good.
Do you have like standard designs for those bridges that you're replacing?
We do. One of our bridge engineers in bridge design designed them a few years ago. Carl, raise your hand. He's gonna keep them up to date, or somebody in bridge design when they change their design criteria, but that's.
And then do you need permits when you're doing that water work?
Oh, what is that? No, because it's all state cash. This is all operated with state funds, not federal.
So as far as budget and cost goes, how many do you replace a year? How much does it cost, like on average, to replace one? And how much money do you have to replace those bridges every year?
I'll give you span counts, because some bridges are 4 spans, some bridges are 8 spans. We do about 20 spans average a year. Depending on where we're working, the time will take longer, or it'll be more expensive if we have to splice more piling. So in South Louisiana, having to drive 160 feet of pile will take some time because we have to do splicing. In North Louisiana, we can sometimes barely get 40 feet in the ground, and our piling comes in 60-foot segments. But the budget that I get, 1.5, is that correct? It changes. A 4-span bridge, I think, is about $300,000. If we have 2 precasters in our state, if they're in war with each other, we get our bridges really cheap. So lately, we've been actually getting them pretty cheap.
Do you cast in place caps or do you use precast?
We use precast. So we can, for emergency purposes or urgent replacements, this works well because I can almost stockpile bridges, and they stay at the precaster yard until I need them. But I plan projects out, so the districts, they'll give me a list. I try to do a rotation. To be fair, everybody get a bridge, but they'll have a list of, this one's a maintenance nightmare. We want to get it replaced as soon as possible. It's still not going to let for another 5 to 6 years, And then if we end up replacing it, we work with bridge design, like take it off your list. You don't have to go replace it. Sometimes the districts will buy a bridge. If I'm going in their district to replace a bridge, they'll be like, hey, if we buy a bridge, will you stay and do that one too while you're here? And so.
Are you your own inspectors as well, or do you hire a third party to oversee it?
Like construction inspectors?
Yes.
Well, as far as the precasters, our in-house construction inspectors go to the yards to make sure that they're abiding by the plans, and they stamp them approval. And then as far as installation, yes, we're our own inspectors.
Just to be clear, so your Department of Transportation owns the equipment to do this type of construction, the cranes,
Yes.
all that to lift? And
Yeah.
then obviously then your employees are all certified and operators of the equipment?
Yes, they all go to crane operating school, and that's on the job training a lot of times with crane operators. But
I'm jealous.
yeah, well, so a piece of information: Louisiana we don't follow OSHA standards within the department. We have our own safety standards, so I think that helps as far as having your own equipment and operators. Right, in-house we have our own certification program, but we don't follow OSHA's. Some states do, but we don't, as far as our in-house. Not all of our contractors and consultants follow OSHA, but.
I assume that basically you had a scour situation that really resulted in this?
Resulted in bridge replacements?
These crunch beds over here.
Settlement. The piles were deteriorating, not scour, just South Louisiana, peanut butter foundation. The bridge was sinking.
So how much engineering do you actually do out there in driving the piles? Do you actually have boring logs and try to estimate all that?
Yeah, if the geotech section has boring logs in the area, they'll give us a length based on that. If not, we kind of, as a rule of thumb, you're going to be driving at least 100 feet, so we'll start there and see what kind of blow counts we get, and if it's still like peanut butter, we splice another section, see what kind of blow counts we get, and then call the geotechnical engineers out to do a restrike.
So you like to use the old engineering, the E&R pile driving,
Right.
the formula and that sort of thing, right? Mm-hmm. Real fast-moving stuff, right?
Right. I mean, they come out and do a CAPWAP analysis, which we refer to as a restrike, and they give us,
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.